If you're a backend developer, if you are a web developer in today's time, this video is super important for you because in this one, we'll be discussing about how do websites really work on a DNS level? What are top 3 DNS records you should know about, which allows you to bring your project live, and all about that. Let's go ahead and discuss that. If you're new here, make sure you leave a like, subscribe to the channel and hit the bell icon. This is free of cost and helps the channel grow. So building a website completely, programming it with any framework or anything is one job, but actually bringing that website live is a completely different task. Whether how you set up the domains, the SSL part, the DNS, everything should be in place. So in this one, I want to talk a bit about how do domains work. So we have talked a little bit about DNS in the past, so you can refer the past videos if you want to get into that. But in DNS, there are 3 records I want to talk about today: the A record, the CNAME record, and the name server record. These 3 records are super important in DNS. Of course, there are a lot more records which exist, but these 3 records are super important because they allow your website to be functional. Let's talk about A record first of all. Now, let's say you own the domain codedamn.com, right? You have bought it using some sort of domain registrar, whether that's Cloudflare, whether that's GoDaddy, anything, and you want to make your website live. Now, one of the things which you have to do is you have to somehow map this domain name to an IP address. That is like the easiest way to bring a website live, right? The easiest and kind of the only way possible, right? Because your domain name actually needs an IP address. For the IP address, let's say you started a new EC2 server in AWS, and when you create an EC2 server, AWS automatically gives you a public IP address, IPv4, which would look something like 137 point something. It could be pretty much anything in the range which AWS owns. Now, in order to map this domain name to this IP address, what you have to do is in your domain registrar, you have to create an A record where your domain name, which is the main domain, sometimes it is referred as @, sometimes it is referred as the full domain, is the basically what needs to be mapped. And then there's a field for IP address where you would enter this 137 point something, right? Now the way this would work is whenever somebody in the world, this client, would ask to visit codedamn.com, their browser would try to make their way to the DNS servers all along the way to figure out what is the IP address of codedamn.com. And this is the last record they will hit. I mean, if this record is present, this is what your browser would eventually get back. This is what your browser will also show in the networks tab in the browser, right? When you inspect, you get a networks tab and you click on that item and you see the source IP address, right? That IP address is this A record which was entered in your DNS. Awesome. So now you have created an A record for your root domain on, let's say this IP address 1.2.3.4. Now let's say you are creating a subdomain called magic.codedamn.com. And what you're trying to do is that you want this domain to also point to codedamn.com, right? For some reason. Now, some websites do this because they are your hosting provider. For example, if you're hosting on Vercel, you would have seen that you have to enter something known as cname.verceldns.com. And in other cases, you might have your own custom use case. But the point I'm trying to make is that if you go to your DNS now, and if you try to enter magic as a CNAME record in your DNS and enter the domain as codedamn.com, so what you have essentially done is not provided an IP address to magic.codedamn.com, right? In this case, for the root domain, this signifies root domain, which is just codedamn.com. You created an A record with an IP address mapping, but for the magic part, the magic domain, you just created a CNAME for magic. So what this right here means is that this would be the record which would be returned when some random client tries to connect to your system. But at the end of this chain, CNAME of magic record means that your DNS provider or whatever entity is over here would perform one last request and go to codedamn.com to see what is the IP address of codedamn.com, right? So this in nutshell is actually equivalent of writing an A record of magic and then 1.2.3.4, but it's almost like it's dynamic in nature, because if sometime later you change the IP address of codedamn.com, you don't need to update this particular record. This record would automatically get propagated depending on what the value is, right, of codedamn.com. So this is what Vercel essentially does to you as well. When Vercel says that go ahead and enter cname.verceldns.com, what they are actually telling you to do is go ahead and enter a record of 76.76.21.21. I think this is the Anycast IP address they own. But yeah, I mean, this domain over here just resolves to this particular Anycast IP address. And Anycast is something which is very, very interesting, maybe something which we will discuss later. But this domain corresponds to this IP address, at least in today's time. The final record, which is also important, but not really. In real world scenarios, it's not as important for the domain management part because you usually have to do it just once, but this is still important because name server record actually gives the ownership of a particular subdomain and all of its subdomains to another provider, right? So what do I mean by that? So let's say you have something like go.codedamn.com record as a name server to something like ns1.codedamn.com, and this ns1.codedamn.com has an A record of some IP address 3.4.5.6. So this part is very interesting because what's happening over here is that what you are essentially saying is that if I visit xyz.go.codedamn.com, what the browser and what the whole universe of domain name system would try to do is that it will go to this particular record, it will see, okay, the name server of go.codedamn.com and everything beyond that, I mean in terms of subdomain, is handled by this particular name server, right? And the IP address of this particular name server is over here, defined by our A record. So the query for this particular IP address to extract out what exactly is the IP address of this domain goes to a server running on EC2. And this is where the fun part begins. I mean, assuming that this is an EC2 server. And if you have opened a DNS server on port 53, then actually it is your responsibility to return what the IP address of that particular domain is. This is why you would not really see using this as your custom domains. Usually it will be provided by your own DNS provider like Cloudflare or something. But in case you wanted to create your own DNS system, the way you would do it is you would add a name server record to, the branch where you want the DNS to be controllable, add a name server, add an A record. This particular machine actually should be listening on a DNS port 53, at least UDP, and this should be responsible to return. There would be a DNS query and it should answer back that DNS query, and whatever it answers back would be the resolved IP address of that particular domain, right? So if it answers back, for example, 1.1.1.1, it would probably see a Cloudflare page, rather a Cloudflare error page, because Cloudflare would say that, hey, we don't recognize this domain, so something seems fishy. But in a nutshell, in your browser window, which we talked about a little before in the networks tab, you will actually see 1.1.1.1 as the resolved IP address. So this is like pretty cool, and this is something we intend to use in codedamn as well in the coming months, where we would want to give you permanent URLs for your projects. So something like mehul.codedamn.dev would start pointing to your own personal website or personal project, whatever you have deployed. So all of that would involve us writing a custom DNS server, a custom DNS provider, and having all this sort of mapping. But yeah, I mean, this brings us to my final record and closes actually my final record in the DNS system, which is the name server record. If you're watching this video, chances are that you are a web developer who has worked with either front-end, HTML, CSS, JavaScript, React, or backend, and you definitely have seen what an API is. You might have called one API to get some data, show it on the screen, and so on. But when you visit any website or when you visit these APIs, the underlying protocol, which is governing how the communication happens between the server and the client, is called as HTTP, Hypertext Transfer Protocol. This is also something which is visible in your browsers when you write example.com or Facebook, Google, codedamn, YouTube, any website you can think of. That website runs on HTTP protocol. But there are actual versions of HTTP protocol itself as well. That is also a technology which upgrades every decade or so. And the latest version which is running is HTTP 3. So I want to take out this video to inform you you guys how HTTP 3 really works, why that was needed, and what has changed since the last couple of versions. Let's go. So this video won't be a very technical deep dive into what HTTP 3 exactly is and what kind of feature it brings, but I just want to give you a contrast between HTTP 2, HTTP 1.1, why that is needed. So before we start pretty much anything, let's actually understand how this client-server architecture works, at least for now. You're gonna see that client which requests, let's say, some index.html page, it's gonna do over HTTP 1.1. Now what this protocol actually does is that this protocol is built on top of another protocol called TCP. Now TCP is a layer 4 protocol, and by layer 4 what I mean is the 4th layer in the OSI model. So OSI has pretty much 7 layers, starting from physical layer all the way up to application layer. This is where HTTP protocol is, and the 4th layer is the transport layer where TCP protocol is, right? So TCP as a protocol is used by a lot more protocols above the layer 4 as well. For example, SSH can also use TCP. Any other application can also, any other protocol can also use TCP as a protocol. So when you make the request using HTTP protocol, HTTP 1.1, internally it uses this protocol which is TCP, right? And TCP protocol was built very, very long ago. I don't even remember, but at least a few decades ago. Now let's dive a little bit deeper into the communication which we discussed here. So this communication which happened from your client to your server does not happen directly like this. This happens in a way where your client actually goes to some other router, some other system which is sitting on the internet. Let's denote a router with something like this. This router might route your connection to some other router on the internet, which then finally routes it to your main server, right? You can also see this hop, this complete hop, where you will reach a server like 1234 via 3241 and 7285, for example, using a command like traceroute in Linux. So if you write traceroute 1.1.1.1, you're gonna see what I mean in terms of like how the connection gets established. So all of these middleware, all of these routers over here also use TCP, right? Also use TCP like this. Now, what we wanted to do is we wanted to introduce a lot more capabilities in the HTTP protocol. The first capability was obviously like somehow parallelizing the request. Obviously, second one was increasing the performance of a lot of these requests and enhancing the protocol and so on. Now the problem here is that you can upgrade this client via sending operating system updates. For example, if you have Android or iOS or whatever, you can upgrade this TCP protocol or HTTP protocol or browsers in general using operating system updates. You can update these servers through similar OS updates or patches, but it is very hard to upgrade the whole internet infrastructure in itself to support all of the breaking changes in TCP itself, right? Because TCP right now is the underlying protocol which establishes some baseline features like there should be no packet loss. There should be pretty much, two-way handshake basically before any sort of data is exchanged and so on. So this protocol, although is extremely robust and relevant even today's time, we use a lot of TCP protocol, but we felt like a lot of improvements can be made over TCP, right? And until you do that, HTTP protocol in itself and the web, therefore, would always stay behind in a lot of these features which can be unlocked when we upgrade the TCP underlying protocol itself. So of course, we don't have the time to go ahead and update the whole internet infrastructure all across the world, because that will take probably too much time. Fortunately, we also had another protocol called UDP at layer 4, similarly decades ago, right? So this UDP protocol right here, you can think of this as a bare bones or minimal protocol just for transferring data, right? UDP mostly just throws your data to the remote endpoint, doesn't care if that endpoint is responsive, doesn't care if the data packet reached, doesn't care anything at all. And that is exactly what we need for raw performance, right? Obviously, it has its own disadvantages. Like I said, it does not care about packet loss or anything, but you have to create systems which are aware about them. So what we do is we came up with a new protocol called QUIC. Now this QUIC protocol is actually built on top of UDP. So UDP is a layer 4 protocol, and QUIC technically is not, sitting somewhere in layer 5 or 6, but QUIC is an implementation which is built on top of UDP, right? you could technically say that even TCP is an implementation which is fundamentally built on top of, I mean, obviously this is not true in a sense, but the reason I'm writing this in a way is that I want to say that UDP is like a bare bone implementation of a layer 4 protocol, right? And TCP brings its own set of rules and regulations and customizations. So what essentially we are doing over here is swapping TCP in HTTP3. And if I haven't said that yet, in HTTP3, we are swapping the TCP part of this protocol with Quick. Now Quick, of course, because this is built on UDP, this is like a bare bone implementation, but Quick brings in all the benefits which I'm talking about. Not exactly benefits, some ground rules, like for example, retransmitting on packet loss. Quick, for example, also enforces TLS at all time. That means in HTTP3, you can pretty much not have insecure connections at all. You cannot have an HTTP website when it's running on HTTP3, right? And obviously, because Quick is almost like a 20-25 year later implementation, we have got much more aware about what the current state of internet wants. And this has been designed in such a way which overcomes a few limitations which we have in TCP today. So the bottom line here is, if this is too overwhelming, let me just summarize this real quick. The HTTP protocol, HTTP 1.1, currently uses TCP as the underlying layer 4 protocol. HTTP 3 is going to use UDP as the underlying layer 4 protocol. Quick takes over in the next layer, in the sense that Quick is built on top of UDP, which then transmits it using better performance, parallelizing, packet loss, so that you don't really retransmit the whole file. For example, one quick example I can give you, which is like bad in TCP right now, is that if you're transferring, let's say, multiple files and there's a packet loss, let's say these are 3 files which are transferred over a single TCP connection, and if there's a packet loss over here, then you have to like kind of transfer this whole thing again. But over UDP or over Quick, for example, you would have this flexibility. Quick would be aware about this single packet loss. So you can just bother to transfer only this one instead of like transferring the whole file again. And obviously this is like a very oversimplified thing which I told, so please don't like start a fight in the comment section, but this is like one of the advantages which Quick would bring. And in general, that we were able to learn a lot of new things from TCP are implemented in HTTP 3. Now you might be asking, where the hell is HTTP 2? And in fact, HTTP 2 is already here, but the problem with HTTP 2 is that we tried to do this stuff, but we were bottlenecked with TCP protocol. So although HTTP 2 was standardized in 2015, we soon had realized that, hey, we need an upgrade to HTTP 3. Why? Because we are changing the underlying protocol itself. We are switching from TCP to UDP plus Quick, and that was not compatible with the current standard which HTTP 2 had already defined. So this is the reason why we needed another HTTP 3 protocol, and this is like still being implemented by a lot of browsers, by a lot of servers, and still a work in progress. But yeah, I mean, this is the current state. Port numbers, why they are important, why they are interesting, and what all you should know about them. Let's go. So I'm gonna go ahead and create a playground over here. Let's name it port numbers. Why not? And I'm gonna showcase you how port numbers work with the help of codedamn playgrounds, and how codedamn exposes a couple of ports for you to use. So you see over here, once this playground boots for you, you get a computer, you get a Linux environment first of all, right? Now, what do we mean by a port number exactly is that when you have a computer, like in this case, you have a Linux computer, a proper container working with full Linux environment, you can run a lot of softwares on your system, right? And in order for your software to sometimes talk to other computers, and even sometimes talk internally if they want to communicate over HTTP, they have to allocate certain ports to their own processes, right? So ports, think about ports as small windows in your house. So if your house is a computer, a window or a door is a port, which is way for traffic to enter and exit, right? And of course, you can build ports which only you use within your house. That is, using it only on localhost, and you can have ports which are exposed to internet, which allow other people to send and receive traffic from your house, right, your computer. Okay, so in this case, let's understand the default command which actually runs over here. So you see the default command which runs on the codedamn playground in HTML playground is static server, then -p, then -1337, and this is no cache, is just to avoid caching by the static server. So what this means over here is the moment we run this static server -p1337 command, you can see that it says me that serving files at localhost :1337. This means that a 1337 port has been exposed within this computer itself for you to use. And if we open this in new tab over here, you're gonna see the URL structure for codedamn is as follows, that you have a random subdomain.codedamn.app and then the port number which you used over here. So you see, just like in local computer, a local system, the moment you expose a port, it gets exposed to localhost, right? Localhost is a special word which means your own computer itself. But over here, right here inside this terminal which codedamn is running, you cannot really get to this computer with localhost, right? Because localhost is your own computer, not this one. But what we can do is we can further expose this port on internet itself. So you see that you are able to access this machine, you are able to access this computer with forclass.codedamn.app, but you also want to get into the application itself, because this over here, this part of the domain, which in your local case would be localhost, is just your own computer. That just gives you the IP address of the machine, of the house. That's the address of the house, right? It's the location of your server. But how do you get to the specific application which you want, right? You get it with the port number. Now let me actually show you a real quick example of creating another terminal over here. And let's say over here, I write, or maybe let's say I create a directory second HTML, right? And if I go ahead and create this, go inside the second HTML, actually we can just do it from here. And I create a second index.html file, and I just say this is something like, let's say this is, so what this is doing over here, we just created a second HTML document. I'm gonna go ahead inside this folder and write the same command, but the only difference this time would be that this command over here would have the port number. Let's write it again from scratch. The port number would be 1338. And then let's keep it no cache, right? So now we are listening on port number 1338. Now remember, I told you that we have exposed these couple of ports 1337 and 1338 for you. So now if you visit 1338, you're gonna enter into a different room in the house, right? This is a second document. If you go back to 1337, you're gonna see that you still have that room available to you. So these are two servers which are listening on two different ports, right? And for obvious reasons, you cannot start a server on a port which already was occupied by someone else, right? Because just like you cannot build a room on a room itself, you cannot also start a port on a port which is already occupied, right? In this case, you get that address is already in use. So yep, I mean, for codedamn playgrounds at least, for your local system, it will work for every and any single port, whatever you write over here, 133.7.8.9, then 134.0.4.1.2.3.4, all of them would be available on localhost and 133.7.8.9 and so on. In our case, when you expose something to localhost 1337 and 1338, we give you the ability to open it in a browser with a shareable link itself, right? So localhost is not shareable. You cannot send it to someone else because their localhost would point at their system. But this link over here would be pointing at your machine because that's how the infrastructure in our case is configured. But the port part still remains the same, right? If you are running a couple of applications, maybe the front end on 1337 and the back end on 1338, in this case, it's not started, but you get the idea that you can link your 1337 port back front end with 1338 port back end, and it will work on internet itself where you get the HTTPS certificate and all that good stuff out of the box. So that is how port numbers work in a nutshell. They are like little windows and doors in your whole house, which is your computer, and the processes can sit on these port numbers. How codedamn playgrounds work by actually using something known as dynamic DNS. Now, if this sounds like a huge term to you, then don't worry, because I mean, when I came across writing a DNS server and how we have to do that, that was exactly my reaction. What is a dynamic DNS? How do you deploy it and all that stuff? But it's relatively easy once you do it. in a hindsight, it seems like, oh, this was just another program or just another software which you have written, but it is a beautiful concept. And let me just go ahead and showcase you how codedamn playgrounds today work with the help of this thing. All right, so the first thing I'm going to do is navigate over to the codedamn playgrounds, and over here you can see I already have a couple of pages, but I'm going to go ahead and create a new HTML CSS playground. Let's say dynamic DNS demonstration. I mean, it doesn't really matter because this is just a playground for showcasing you how the playground itself is working. So you're going to see that it boots up in a few seconds. And the moment it boots up is something interesting happens. You see that we have a domain on the right, which is watchattack.codedamn.app. Right now, in this case, this is random, and it will be random whenever you reload this, because our current infrastructure, the way this works is that it assigns you a random domain on any single reload, right? You see now it's beltmoney.codedamn.app. So you see that it's a combination of a couple of random words, .codedamn.app, and then the port number on which your container is listening as well. So you see, if I write static server p1337, no cache, hit enter. If I go ahead and take a look over here, you're going to see that it starts working on 1337. If I do the same thing, but let's say on port 1338, you're going to see that it starts working on port number 1338, just like you would expect to write localhost 1337 and localhost 1338, right? But the only difference is, at least for now, at codedamn, we only expose these two ports, 1337 and 1338. And by default, only this 1337 port is embedded on the right. Now, this is fine and good, but the really interesting part is that how this subdomain, which is dynamically allocated, automatically gets connected to your instance, or this container in this case. Now, in a broader sense, in a overview, a bird's eye overview, the way codedamn playgrounds work is that this is a Docker container. Right, this terminal which you see is a real Linux computer connected to some computer in the cloud, and this URL which you get is basically the URL which has to resolve to two things. The first thing is the physical server of this, that is the actual IP address of the server, and the second thing is this container itself, because on a single container on a single server there are multiple Docker containers running, right? So we need two things to reach to this particular container: the IP address of the physical host and the container ID or some sort of identifier, so that we can identify which container it is within that physical server. All right, so how does this information help us convey which IP address which we have to reach? It doesn't, and that's the thing. This subdomain over here actually has no information in itself embedded where it has to be redirected or which IP address it has to be resolved. So how does this get this 165.22.46 and 102? Now for this, we have to actually see how the DNS is resolved for this request, because remember that DNS is the actual thing which whatever DNS server responds, the browser visits that particular URL. So in this case, we had to write our own custom DNS server. That means this over here, when Chrome asks my ISP and then my ISP asks some root level.com TLD, in this case .at TLD, and what is the IP address, then it gets redirected to Namecheap, for example. Any chain of ISPs, doesn't really matter. The final server which needs to return this is our server. That is, we say that, hey, the IP address of beltmoney.codedamn.app is 165.22.46.102. And where does our server take place in that case? All right, so the way it works is the follows. So I'm going to go ahead and write a command in CLI, which obviously I don't expect you to understand. But what this command actually is doing is that it's extracting something known as authoritative name servers. Now, what authoritative name servers is like I said, the server which is at the end of the chain, which has to respond the IP address. That particular server, where is that server? What is the IP address of that server? So if I click on enter after writing, if I hit enter after writing this command, you're going to see that actually gives us the authoritative name servers for codedamn.app domain in this authority section over here. So you see that authority section contains these two name servers, ns2.codedamn.app and ns1.codedamn.app. And the A record, which is basically the IP addresses of these computers, are also passed in the additional section. This means that whenever anyone wants to resolve any domain at all on codedamn.app, abc.codedamn.x, app.xyz.codedamn.app, codedamn.codedamn.app, anything, it has to ask these two servers finally. This is the responsibility of these two servers to respond to what the query is. And guess who controls these two servers? We do. So these two servers are actually deployed in two different regions in AWS, and these servers are actually running on EC2 instances, right? So these are EC2 servers which are running as DNS servers, right? So it's not like we are doing any sort of communication to some other servers. It's like it's receiving communications from routers all over the internet, right? So if you are sitting in India or US or UK or Canada, it doesn't really matter. And if you visit this domain, finally, some IP address in the chain is contacting these servers and asking that, hey, do you know the IP address of this? And this server has to respond. Yes, because if it does not respond, then, you would get a page like not found, something like that, which you see that the IP address of this domain cannot be resolved. So you see, these two servers are the real deal. And I can actually over here directly query them as well. So you see over here, if I write ns1.codedamn.app, and you can see I'm also writing @this IP address, which basically means that I want this server over here to resolve my query. But in this case, it wouldn't really matter even if I remove this, because this is the authoritative name server anyway, so it has to answer this. So you see, when I do that, it actually returns me the same IP address, which is the NS1 itself. If I do the same thing with built money, you're going to see that it returns me the same thing. So I can say this thing, but instead of NS1, I can just say builtmoney.codedamn.app, and it's going to just say me the IP address, which is over here. And this IP address, mind you, which is running on this DNS server, is dynamically computed, obviously. So let's take a look at an actual picture of the code which is really running on these servers. You can see over here, we have hard-coded responses for NS1 and NS2 subdomains, which is fine because, if I want to get an A record for an NS1, I cannot really ask the server itself because that is the server. And the second thing is, if it is not NS1, if it is not NS2, then we perform a DynamoDB query, which includes the subdomain as the key, and we get the IP address out of it. And the way this DynamoDB gets populated is when your container gets booted, which is something which we'll discuss in some other day. But the idea is that this is the place where we get the IP address. We get it from a table. It's kind of like a lookup, but instead of having fast or file-based lookup for an IP address, just like you would have an etc host file or anything like that, we actually use a DynamoDB so that it can be programmed by other microservices running as well. And once we have that, we just create a DNS response, return it, create a record, and return it as well. So you see over here, whenever you request a change which propagates to the server, we perform a DynamoDB request to extract out what exactly should be the host or the physical host for this. Now, how do we get to, let's say, the part where this container is linked to the physical host? That's something for another day. But yeah, that's how basically our dynamic DNS server looks like and works like. And I would love to see you guys also building a lot of cool stuff, a lot of cool projects over here, because we have been making a lot of changes to CodeDamn Playgrounds, and you're going to be surprised with the amount of changes coming at CodeDamn in the coming weeks and the coming days. So stay tuned, make sure you like and subscribe, because I have a lot to share about CodeDamn Playgrounds in the coming few days. And this is basically a fully functional IDE at this point, where you can start servers at different ports, have a couple of terminals, have any sort of repository, program basically the whole playground as well with the YAML-like syntax, and a lot more. So there's a lot of content which is needed for you to also educate in terms of how to work properly with Playground, but that should be a good start. If you have taken any interactive course on CodeDamn, by the way, which I highly recommend you should, especially from our full stack developer learning path, you know about this concept where in an interactive course on CodeDamn, you not only just learn by watching videos, attempting quizzes, but you also practice in browser, right? Most of the courses, whether that's HTML, CSS, JavaScript, any sort of course is exactly like that, where you also get to build projects and practice right within the browser without leaving your computers, interface or without changing any screens or tabs, because the whole IDE opens in your browser interface. In this video, I want to discuss how actually that works, just to give you under the hood glimpse of how these complex things are actually simplified and presented to you on a simple web-based UI. Alright, so if you visit any lab on codedamn in any course, or if you even open Playground on codedamn or attempt a project on codedamn, what you will see is something like the following boots up, where on the left you would have your file-based navigation, below you would have your terminal, and in the center you would have your editor, right? And maybe like a split screen with a browser window as an iframe embedded as well. Now, the major component of all of this is actually a backend computer, and I should say like a backend container running on cloud, right? So what this web-based UI is that it's a simple UI for this container running in the backend as a Docker container, right? So let's discuss a little bit of how that works on codedamn today in this video, just to give you a sense of if you wanted to construct something like this, how would you do that on your own? So the first thing is that we need to spin up a container over here. Now there are two parts to this: spin the container and then make this container respond to some sort of API calls via outside the container or via from the browser. So make the container public in some way. So the spinning part is relatively easy. I mean, you just run docker create container command and it just spins you a new container on a physical host. This part is also relatively easy if you think about this, because just what does it mean to make a container public? That means you need to be able to program this container somehow, and you need some open ports on this container. Ports which are routable from an internet address. So if you open this area, for example, of Playground, you would see that you have an actual URL you can access to browse the website, which is visible. Now this URL is something special because it allows us to get access, connect internet basically to the container. So if you look at codedamm's URL, which you get in the browser, you would see something like the container ID -IP address .dns.codedamn.app, and then a port number, whether that's 1337 or 1338, any sort of port number here. So this part here is the container ID which we pass, which is like a 6-7 length of string, and this part here is the IP address of the container, right? So what we do is that when you start a container, we dynamically route this request to this physical host as an IP address, which has Docker running, and it maps all the requests to this particular container which is available. Now, if I want to discuss the architecture of this thing, it looks something like this. So you have, at the very end, you have a container which is running, right? This is like, let's say this is DC, a Docker container. Now this thing is running inside of a public, a big computer, probably like a huge EC2 machine. Something like that. This is like a small container which is running inside this EC2 machine, and this container right here has a bunch of ports exposed, right? So it's some of its port mapped to some random port inside container on the physical host and so on. Then on this container we have another reverse proxy process which actually listens to connections, incoming connection, and I think I have just drawn the directions of arrow a little wrong. It should be something like this, right? Or maybe it could be the other way as well, but initially when you're getting traffic, that's the direction. Then finally, in front of this reverse proxy, you have your client, right? So this is you like completing a project or browsing a lab on codedamn. So when you visit this URL, the first thing which happens is that we route your address to this particular server right here, which is, the information is included in the IP address. Once you hit that server, you get into that reverse proxy area on the server, which calculates which sort of container you want to, just contact or communicate with the URL part. And it also takes out the port number which you're trying to look at. Then it will find the associated port number on the main host, the physical host which you're looking, and it will connect you to that particular port on the physical host, because this port is mapped to that another port inside the container. Right? And then finally you get routed into that container because, hey, you hit the right port, right? Which was also running on the main container. So you would get a nice hello world response from codedamn. So this is how, like internally, how we currently work. I mean, this is of course a work in progress implementation. This is not something we would use forever because we would obviously need to change this URL structure or URL format if you want to support more, like long running processes or long running containers. But I'm telling you right now in 2021, this is the way codedamn playgrounds and labs and all that dynamic functionalities work. Now, the second part of the equation is how do you scale up this server right here, because this server we limit it to like maximum of 10 to 20 people at max because we don't want the server's resources to be overloaded. So how do you upscale this server? And I mean, some companies, some people do prefer to use solutions like Kubernetes or some custom solutions, but we currently don't use that. We currently use a little bit of mix of DynamoDBs to store the information about these multiple physical hosts. So this DynamoDB would actually store information about all the physical hosts which are running, right? And then it will connect if there's any new client. The DynamoDB lookup would run. It will see if there's any empty container on any physical host. If yes, it will just respond it to the client, just like in the following fashion. Like I said, if no, then it will spin up a new instance, and not exactly DynamoDB. There's obviously a script here as well, which is running on the Lambda, but it will spin up a new physical host right here and it will add it to the collection, and then, the process repeats. So yeah, I mean, spinning/scaling is first part. Making the container public is the next important part. And I mean, this third point is pretty much the second point itself. But yeah, I mean, a lot goes behind that 2-second thing, that 2-second delay which happened when you start the lab, right? When you see that progress bar at the end, at the bottom, loading the state, or when you see that spinner in the browser just, going around and around, you should understand, you should realize that a lot is happening on the back end on codedamn. So the next time you're building a project on codedamn or doing an interactive lab, you would be able to appreciate a lot that goes behind that. And I mean, this is just the theoretical stuff. In the actual practical implementation, of course, you have to take care of 1,000 more parameters. So that is pretty much it, how codedamm's project playground lab area works. If you like this, I would recommend you to just go ahead and play with this with a simple HTML project. I mean, you would probably see one example of a project on codedamn on your screen right now. But yeah, I mean, if you liked it, make sure you leave a like, subscribe, and complete a project and complete a lab. That will actually be really fun for you if you like working with new technology. So that is all for this video. I'm gonna see you in the next one really soon. If you're still watching this video, make sure you comment down in the comment section, I watched this video till the end. Also, if you're not part of codedamm's Discord community, you're missing out a lot on events which we organize on a weekly basis to code. You already know the drill. Make sure you like the video, subscribe to the channel if you haven't already, and thank you so much for watching.